morning, everyone. Welcome to this Ironside Take30 with the data science session. Today's focus is going to be a predictive analytic in banking. Before we get started, I just want to kind of give a brief introduction about myself. So I'm a senior data scientist at Ironside. Before I became a data scientist, I got my PhD in economics, and I work for Moody's Analytics for a few years as an economist, where I help consult banks do a lot of loan projects and do risk management and pricing model and loan underwriting model. So I have a lot of experience in the banking industry, and very excited today to share my experience and my knowledge in this space, and also see how we can help you guys. So the agenda today is first, I will discuss where the banking industry can benefit from predictive analytics. And then we're gonna also go through AscentAI quickly. And then we'll walk through the process of predictive analytics in data science, followed by help understand how precisely location intelligent data sets and their impact on analytic models. All right. So if you guys attended a previous Take30 session in banking industry, we sort of covered this data science as a service approach. And for that Take30, Pam gave a very kind of big picture overview on this AscentAI offering and how we can help in the banking industry. So today my focus will be actually zoom in the bread and butter of AscentAI offering here, which is machine learning modeling, and in particular the predictive analytics. I just kind of want to give a brief overview again about AscentAI. Usually you do a use case discovery, so we help you understand how we can utilize the data you have to discover some or address some problem and issues. And then we will do a rapid variability assessment to understand whether it's feasible to move forward to do the machine learning modeling. The next stage will be developing a machine learning modeling that is production ready. And some of the customers kind of stop here. They were also just wanting to have the analytic part, but some customer will move forward to the AI implementation. The benefit of that is that will offer you the opportunity of performance monitoring. So with that, I'm going to move to this predictive analytic. So let me talk about predictive analytic a lot. Let me just kind of offer sort of a definition around it for you to understand what really is predictive analytic. It really is just trying to establish or capture relationship between a lot of explanatory variables, or you can call it features, and the predictive variables, or you can call it target variables, from the historical data that you provided to us. And then based on that model we have established, we try to do forecasts to predict the future or prospect outcomes and performance. So as the drawing illustrate here, or the cartoon illustrate here, it's not actually all about how fancy the model is, how complicated the model is. I'm going to cover later that really the key is the data quality. So now I'm going to first talk about how we can utilize predictive analytics in banking. Here is a few use case here. So like I mentioned before, when I was working at Moody's, I did a lot of loan performance prediction and forecasting. The main goal there was really to help banks to manage the risk. And also a lot of times it's just to fulfill the regulatory requirements so they have enough reserve if anything bad happened in the economy. And then the next one use case is to predict the branch performance. So you know whether you want to keep certain branches and also do more investment in those branches versus maybe close down on certain other branches that it's not performing or not receiving as much demand. The next one is predict the probability of existing customer to use other products. So cross-selling is always a very successful strategy to get more revenue. So here you're trying to understand what's the chance existing customer can buy other products. And the next one will be loan underwriting and loan pricing. So that's a little bit similar to the first one, but the goal is different. So to understand what's the probability of a loan that would default, you will actually use that to guide your decision to decide whether you want to underwrite certain loan to certain customer. And also the loan model, predictive model can be used to do better pricing for different customer. You offer different rates. So here, yeah, this is other examples of banking. There are still a lot that I can cover here, but let's move to the next one. I'm going to talk about just the process of predictive analytics. So the first most important part of predictive analytics is really assembling all the data and make sure the data quality is good. Here, I'm kind of just give an example of a typical banking project, what kind of data we'll be looking at. So first, you start off with internal data. Typically, you're looking at 3 levels of details. One is customer level data, and the second one is account level data. The next one is branch level data. So customer level data, you want to understand who are the customers, what's the key attributes. The most important factors usually are what's the income, and then FICO score to measure how risky the customer is, and LTV, loan to value ratio, DTI, debt to income ratio. All those just kind of measure how affordable the loan is to the customer. And there are also other characteristics that you want to consider for deposit accounts. So for account data, we have different kinds of account data. One is more static account data, which focus on the account characteristics. So what kind of product type is that? How many years is that loan? And when is the loan originated? And also what's the maturity date of a CD? And all those sort of feature of the account. And then the next will be account dynamic data, which includes all sorts of transaction and balance data, perhaps at the daily level. And the next one will be branch data. Usually you're looking at the transaction information. So internal data, all the banks will have the internal data. So what really separate us from other vendors or even some in-house data science team is the strong offering of this external data to enrich the model, to further enrich the model. So when I mean external data here, it's particularly focusing on economic data, because for banking industry, the most important factors when you look at more broadly external data would be economic factors. So if you look at depending on the level of depending on what kind of aggregation level you're looking at, if it's a national level, then it's very simple. You get it from census, just employment rate, household income, population size, those key social economic variables for macroeconomic data. And then we were able to distinguish ourselves from other people because of this partnership with Precisely, and we were able to offer a more granular level economic data. So let's go to the next slide. This is the Precisely data. What's really the most attractive thing about Precisely data is they really provide a different geographical level of details. So you have similarly, you have the demographic information, you have the crime index, and you will have property attributes. So if the bank has a lot of real estate customers, property attributes could be very useful information, and you'll have the boundary information. I want to kind of point out this points of interest. Points of interest sort of provide the information on if your customer are business customers, then the points of interest can provide business level information, like what's the employee count, what's the revenue size of that business, provided that if your customer are business focused. And but it does depend on the data quality you guys provide to us to make that merge possible. So yeah, this is the precisely data. So we talk about the data, assembling data, talk about how important it is to have good data, a lot of information. The key of model success modeling, it's all about feeding the model as much information as possible. In this case, as much variable or as much data as possible. And after you have all this data, the next step will be feature engineering. So here, feature engineering, we're calling a little bit of a domain knowledge. Sometimes you want to recategorize product into more meaningful groups. Most banks have tons of product offerings. If you just throw those products into the model, do a one-hot encoding, you're gonna not have too much luck out of it because it's going to be a lot of very sparse metrics. It's hard to identify the impact of different products. So you want to do some meaningful groupings. For example, you want to group the loan into whether it's 20-year loan, 10-year loan, 15-year loan, or 30-year loan. And you want to see whether it's interest-bearing account or non-interest-bearing account. And you'll be interested in also grouping into whether it's fixed rate or ARM. So these are just a few examples, but really depending on the product offerings, you can do all sorts of interesting and meaningful groupings to make the prediction more accurate here. And then the next one would be having generate some interaction term between two features. So sometimes it's not just the income that will play a role in the, let's say, the probability of a loan to default. Income will play a role together with another factor, let's say FICO. The higher income always means lower probability of default, but they will but that together with FICO will also make a difference. For example, for low FICO score, then income become much more, then the probability of default become much more sensitive to the income information. And that's why it's important to have the interaction term between two factors here. So after this feature engineering, you basically kind of assemble a little bit more data there. And then the next one will be data validation, data cleaning, data pre-processing. The goal here is really to just have a cleaner data, have a higher quality data based on what you can do as a data scientist. So you would sometimes do normalization in order to scale the variable within a specific range, and you'll want to treat the missing observations. And if the goal is a classification model, then you want to answer a yes or no question. Then you want to balance the data set in order to have more balanced group between the minority class and the majority class. So it could be a loan default or not. It could be most of the loan are not defaulted. So you're looking at very small sample of defaulted loan. It will be hard to do the modeling. So you want to balance the data to have a more balanced two group here. And then it's natural, we're gonna have a lot of noisy data. We're gonna have a lot of outliers. So you can do binning to group some outliers into a particular separate group, and so that the model treat them equally. And then depending on the project goal, you may want to do also data aggregation to a different geographical level. So that's data cleaning and pre-processing. The next one is the most exciting one, that is model selection. So for if you don't have any training in machine learning, you'll just be like playing around with all sorts of model, and just it's always just a command line throwing into the software and let it run. But really, actually, there's a key decision making before you do all this model selection. That is to understand what is the project goal. Sometimes some customer come to us, they simply want to do prediction. They want to forecast the future performance or prospect performance. So in this case, prediction is important. You want to focus on the model prediction performance. You want to focus on, you want to get a model that's as accurate, as precise as possible. So in this kind of situation, usually you want to look out to like random forest, gradient boosting, who typically do a better job in a prediction performance because they are not strongly depending on a lot of assumptions like regression model. However, we also have clients who come to us saying they want to be able to have a model to guide their decision making, in which case you want to know what factors drive, let's say, revenue or profitability. In this situation, then you want a non-black box model, which typically you will resort to regression model, and that will have very good interpretability of the model, and you can also see whether a coefficient is statistically significantly estimated. Then the next one is just iterate through a lot of models and compare their performance and make a decision out of it. As the column illustrate, it is a lot of intensive iteration that you need to go through until you reach a good performance result here. So just keep trying. We already sort of covered the key step of the machine learning predictive analytics for banking industry. Now I just wanted to kind of give two brief examples of how we go through it in the predictive analytic concept. So first is a new branch site selection. So you can use machine learning model to first identify the features that are important for the bank profitability or revenue, depending on your goal. So once you identify those list of important features, then the next step is to fine-tune a model that includes all those features. Then followed by use a predict analytic to forecast the profitability or the revenue on various locations. After in all these steps for the data processing, we also leverage the location data to include all the demographic and point of interest information. Here, in particular, point of interest, we were able to provide information about existing competition. And then the next example is identify profitable customer and products. The reason I list this one here is because it's not about doing a prediction or forecasting. It's actually about, just like I mentioned, it's about understanding what factor drives the profitability. So in this case, again, you use a machine learning model to identify the features, to go through a typical feature selection process. Then the next one, then you want to use a regression model for interpretation, and you look out for the signs, magnitude, and t-statistic of the estimated coefficient to help you understand what feature of the customer or what feature of the product make a product or make an area more profitable. All right, so the key takeaway of this short session is first, bank can use predictive analytics for many use cases. And I like to stress again, good data quality is key for a great data scientist for a good model. External data can be very powerful in boosting the machine learning performance and also give more insights. The example of AI adoption in banking will include manage the loan risk, predict branch performance, predict the existing customer probability of existing customer to use other products, and also the loan underwriting and loan processing. With that, I think I'm open to some questions here.
Yes, we've got a few questions that came in, and just as a reminder, everybody, you can submit them to us as well, but we have a couple already. So I'll start with this one. How do you treat missing observations?
So we have a lot of ways to treat missing observations. The most obvious thing is to drop those missing observations, but provided that we have enough observations, and then the missing is not significant. So the simplest thing to do is to drop those observations altogether. And then the next, but sometimes we don't have the luxury of dropping all of them because the data set is small. Then we're looking at imputing techniques. Sometimes it could be as simple as imputing by the average of a year or average of a month for those attributes. Or fancier than that, you can also even try to do some extrapolation. So to extrapolate from previous months or previous years, and even more fancier, you can even try to do some sort of modeling to see what kind of factor will determine the value from existing data, and then you do a forecast, sort of a predictive analytic here again, and you do the forecast for those missing value. But usually, once you have missing, whatever you do is going to generate some measurement error. So something to keep in mind, that measurement error will definitely make the model prediction less accurate down the road. But that's something to keep in mind. And yeah, so that's a few ways to go around about missing observations.
Okay, great. Thanks. We have a couple more. So the next one is, since you stress the data quality, is there anything you as a data scientist can do to improve the data quality?
Yes, so as a data scientist, we're not magician, but we definitely can do something to help improve the data quality. Like I mentioned here in the data pre-processing, really part of the goal is to improve the data quality and prep the data for modeling. So let's look at this few example. Treating missing observation is one thing to improve the data quality. And also, like I mentioned, the binning method, it's natural for any data set, especially with significant amount of observation, to have some outliers. But do we trust those outliers? Probably not. But do we want to really single out all those outliers and then use them in the modeling? Not necessarily. So in that case, you do a binning method, which will afford you to group all, let's say, 5 percentile of the data into one separate group, and the machine learning model will treat them all equally without really taking into account how big that value really is. So yeah, that's another way we can help improve the data quality. It's a natural thing for data to have outliers. But like I mentioned, we're not magician, we can't do everything. If data is not there, quality is not there, there's only so much we can do. But really, there's also more you can do to improve the data quality through the data management and data engineering. And we actually have a strong suite for helping with data management and data engineering. And if you are interested, you can contact here to help at ironside.com under my name here. I hope that helped answer the question.
Yes, definitely. That's awesome. It looks like we have one more unless any others come in, but the last one says, what geographical level does Precisely data cover?
Good question. So Precisely data, let me try to jump to the Precisely page. So the best thing about Precisely data is they can go to as granular as a block group. Although, is it necessary for most of the project? Probably not, but we do have like block group, census tract block group, and then zip codes, county, city, metropolitan area. So whatever sort of geographical level you're looking for, Precisely have that. It really just depends on the project goal, and also sometimes it just involves a discussion between data scientists and the business side of people to decide what geographical level to adopt here.
Xinping, I just wanted to add in on that because I do know that Precisely also can go to like a lat long and address level, a multi-tenant address as well. And so I just wanted to share that with the group.
Yeah. Oh, good point. Yes, thanks for mentioning that. Actually, I totally missed that because when I was thinking about Precisely data, I was particularly thinking about use that to enrich the economic data to do the modeling. But thanks to Debbie for bringing out this at address level, and you actually you can go to address level for things like point of interest. You are able to identify a business attribute, like I mentioned before, the employee count, revenue size, all sorts of business level information. Does that answer the question?
Yes, definitely. So unless there's any other questions that people have, I think this should be good.
Yep, we're right on time. We still have 1 minute if anyone has any questions. And again, you can always reach out to here to help at ironside.com. And we're gonna also share the slides for future reference. Thank you so much for your time.